Let's move on to the first session on the theme of Next Generation Energy Markets and Global Trends. Stakeholders' role in fostering climate technology. To begin with, we are honored to have Ms. Ashley Grosh, Vice President of Breakthrough Energy, deliver her keynote presentation. So Ashley, the floor is yours.
Thank you. Good morning. It's wonderful to be here with all of you. Thank you for hosting me in Tokyo. I'm going to tell you a little bit about what breakthrough energy is and the problems that we're trying to solve across the world. And then you'll get to hear from some of the amazing innovators and their technologies that we've supported. So breakthrough energy was started in 2015 by Bill Gates as he recognized we needed a new vehicle to think about how we're going to support the energy transition. We needed patient capital. And so we know that we have to find a way to remove 51 billion tons of emissions per year in order to get to a more prosperous future. There were two themes that emerged when breakthrough energy started. The first was that we were going to focus in the deep tech and the hard-to-abate sectors. So everything we fund at Breakthrough Energy has to demonstrate it can abate 500 million tons of CO2 per year at scale. This was our first principle. Our second principle is that we were going to focus in 5 grand challenge areas: manufacturing, electricity, agriculture, transportation, and buildings. You can see the emissions there. But so these are the hardest to abate sectors and the largest emitting sectors. So we've set up a platform today to do this, to think about commercialization from an end-to-end approach. We have a platform with 3 different layers: discovery, develop, and deploy, that can support innovation from its earliest stages through company building and then finally through development. I have the pleasure of leading the discovery program. This is the earliest stage of the funnel. This is going furthest upstream, finding innovations that are the ones like here today. These are new PhDs, new technologies, new IP that are coming out of universities and national labs. This is a critical phase that we need in order to keep a healthy pipeline of innovation going. This is pre-seed. This is where we spend time de-risking the technologies. They go through pivots at this stage. We make sure that they get their product market fit correct so that we can hand them off to customers and to the venture community. I'll talk more about our Signature Fellows program that we've developed in this stage. Secondly, Breakthrough Energy Ventures, that's our venture capital stage. That's the development stage. Today we have 3 funds, Breakthrough Energy Ventures 1, 2, and 3, about $3 billion deployed across 130 portfolio companies in those 5 themes that I talked about. Primarily, those companies have been funded in the US and Europe, but we are here. We have an intent to be more global and to do more in this part of the world. And lastly is deployment. We launched Breakthrough Energy Catalyst. This is a project finance fund, a first-of-a-kind financing fund. We use blended capital here to demonstrate to the market how we can bring on new technologies like hydrogen, sustainable aviation fuel, long-duration storage. And so this is how we are taking our approach to commercialization, to supporting decarbonization, early from lab to company building, all the way to plugging it into the market. And we can't do this alone. So at every stage, we work with partners, universities, governments, investors, corporates, the smartest people in the world that we can find around these topics to help us. In our flagship fellows program, I want to just point out a couple of things that are unique about how we think about supporting entrepreneurs. So we do an annual call for applications globally, where we get over 1,000 ideas that come into the funnel. These are PhD students or postdocs that have amazing new breakthrough ideas. We ultimately down-select an annual cohort of these projects. We provide them capital, mentorship, and other features that I'll talk about. But also, they've never worked in a company before. So they have a technical idea, but they need a business partner. So we also, in addition to funding the Innovator Fellows, we fund Business Fellows. And so those are people that have worked in industry, that have built plants, that have commercialized a technology before. So they come in to help our innovators as fractional CEOs. Why are we so focused on the early stage? Well, we believe that nearly half of the emissions reductions needed by 2050 are to come from technologies that are not even invented yet. And so that's why we're spending time upstream, thinking about where the new innovations are going to come from. And we know that these early stage technologies in deep tech require a different set of resources. So that's what we bring to bear through this program. As I mentioned, fellows globally come into our program. They receive funding. They receive an initial $500,000 to support R&D and to allow them to do this full time. They receive access to our curated curriculum. They receive access to global partnerships and hands-on support from other technical folks that we have at Breakthrough Energy. And most importantly, access to a global network. If they were to go at this alone, it would take a really long time. So our goal through the program is to accelerate their path to commercialization. Here at this stage, we're asking people to take risk. That's what we want you to do. That's where the innovation is going to come from, but you have a lot of partners behind you supporting you. So where have we been on our journey? Since launching this about 4 years ago, we have over 120 fellows globally, almost 60 projects in 16 countries. So we now really have a playbook. We're now reaching the smartest innovation hubs across the world, and we're bringing it into a hub model. And so now we've launched our first hub in Southeast Asia with other partners that we announced last year in Singapore. And we're now spending time here in Tokyo thinking about a potential hub here. This is a little bit more about our Southeast Asia program. As I mentioned, we can't do it alone. So when we go to build a hub, we look to build partnerships and bridges with academic institutions and universities. We look for other co-funding partners, so sovereign wealth, government funds, corporate foundations, other impact investors that want to help us scale this program. And today you're going to hear from Linkor, one of our technologies that we funded in the initial cohort in Southeast Asia. You're also going to hear next from Aikido, from BingBin, that's also been part of our global program. And so I invite you all to listen to these amazing entrepreneurs. They are the real heroes of this program, but we're excited to engage with you. I'm excited for you to learn more about what they're working on, and please find ways to reach out to Breakthrough Energy. It takes a village to do this work, so we need partners throughout the ecosystem. All right, now I'm excited to bring up BingBin from Aikido to share more about their amazing energy solution from the sea.
Hi everyone, my name is BingBin. I'm the Chief Engineer and Co-founder of Aikido Technologies, and we are Breakthrough Energy Innovator Fellow of Cohort 2. At Aikido, we're developing innovative floating foundations for wind turbines. In other words, we're making energy float. Okay. I think you all know very well, as an island country, Japan's energy production relies heavily on imported fossil fuels, and that make it vulnerable to global market disruptions and supply disruptions. But on the other hand, Japan has a vast resource of wind energy, especially offshore wind. And the offshore wind itself has the total potential to cover 10 times the electricity need of the whole country. So we really believe that wind could be the future of Japanese domestic energy production, that it provides independent, secure, and resilient energy that Japan controls. And on top of that, wind also helps reduce carbon emission, and that helps Japan to reach its 2050 net zero goal. That for the big cities in Japan, that means cleaner air, healthier residents, and a resilient infrastructure. So according to Japan Wind Power Association, by the year of 2050, it's projecting that 1/3 of the country's energy production will be from wind, and out of that, 60 gigawatts of capacity will be from floating wind. Why floating, you may ask? Currently, there are two main barriers hinder the wide-scale deployment of wind energy. One is from local opposition, from people living near a wind farm or just be able to see one wind farm. On the other hand is the limited land area that we always have to compete with other human activities. But once you put a wind turbine on the floating platform and put it offshore, and we can solve both challenges. So the floating wind farms can locate more than 10 kilometers away from shore where it's barely visible. But in an engineer's eye, it's still pretty close to urban load center. That means the electricity can still be transmitted efficiently back to big cities on the coastline. But traditionally, floating platform production is difficult and expensive. The current design concepts usually are borrowed from oil and gas. They are complex and labor-intensive. It requires a large space and a lot of labor, a lot of welding in the final assembly. And each of these units is as large as a football stadium. So that is a very big scale problem. And just reflect on the first slides, to be able to meet that 60 gigawatts of capacity target by 2050, we need to build 100 units of these giant platforms every year. And here is what Aikido wants to do differently. Last year, with the support of a Breakthrough Energy Fellows program, we were able to do our quarter-scale pilot project we call Aikido 1. And I guess no words speak better than the video. So let's play the video. It's a quarter-scale project. Each of the column you see has 10 meters in length and 2 meters in diameter. And the major components are lifted into the support frame underneath it, so that will hold them in the right place relative to each other. And then we perform the pin insertion that will connect all those components together. And like traditional designs, there is no welding in this final assembly stage, only pinning, and that saves us a lot of time. And as you probably already see, the uniqueness of Aikido platform is in final assembly stage. The platform is laying down and it's folded up at that stage, and that saves a lot of space. So once the platform is fully assembled, we put it onto a barge and then push it to the final stage, to the test site, where we lift the frame up and drop it into water, where the platform will float away from the frame, and then we push the platform while it's floating for the last mile. Once we get to the final site, we connect the platform to the pumps on the right-hand side of the little red barge, and then we perform this operation we call upending, where we only pump water in and out of the columns, and we were able to extend the columns out and then stand the whole platform up. So in real projects, after the platform is stand up, we'll install a turbine onto the center column. You see the white column in the center. But here, for this pilot project, we stopped here because we already demonstrated the key innovative thing that of our design with the support of Breakthrough Energy Fellows program. So as a summary of the video, the Aikido 1 pilot project successfully demonstrated the key features of our design. One is we validated the final assembly process. It was performed in less than 40 working hours, compared to traditional designs that may take several months. And the upending was successfully proven in realistic conditions, and it was done in less than 2 hours. And of course, we learned valuable lessons in this whole process that can inform our next generation design and fabrication method. So really the key idea of Aikido is we are designing it for serial production. With this folded configuration and pinning methodology, we're able to increase speed and save space in final assembly, which is usually the bottleneck for traditional designs. We were able to reduce the footprint by 67% and reduce the assembly time by 90%. And also the modular design of the platform that we unlocks fabrication production, factory production, and serial and distributed supply chain, and that will give us massive savings. And it's simple. There is no active system once the platform is deployed, and that will reduce operation and maintenance costs. A little bit history about Aikido. So we started in 2021, and at 2023, we became Breakthrough Energy Innovator Fellows, and that was critical to bring our technology outside of the lab. The business fellows help us really rethink and refine our value proposition, and the technical management team really helped guided us and supported us through every milestone and pivot points. And also the funding that gave us the opportunity to bring the technology from the scale on the very left-hand side to the one that's at the tablet scale where you can stand on top of the platform. And we are still growing. Right now, we are building capital stacks for our full-scale demonstration, and we hope to deploy in the 2027-28 timeframe. And by the 2029, we hope to commercialize our design. So a little bit more about our full-scale demonstrator. We call it L60, and it has the size to be able to bear a 15-megawatt turbine. We have locked the deployment site in the North Sea area for 2027-28, and it will be announced in a couple weeks. In this project, we hope to build a low-cost, scalable offshore wind supply chain that flow through APAC and supply all the components for us where we'll perform the final assembly and deployment in the North Sea area. The construction is to commence in 2026. Okay, hopefully at this point you'll agree with me that floating wind is cool and it could be our future energy solution. And what Aikido is trying to do is reduce the cost and increase the efficiency for floating wind deployment. So if you're interested, and we are looking for investors and partners, and if you're interested in Aikido or in our full-size demonstrator, please come find me, and here is my contact information. So again, we are Aikido Technologies, and hopefully together we'll make energy float. Thank you very much. Okay, now let's welcome Sai to the stage to talk about Linkor.
Thanks, BingBin. Hi, everyone. My name is Saikiran. I'm the co-founder and CEO of Linkor, a current Breakthrough Energy Fellow based in Singapore. At Linkor, we are focusing on extracting critical materials such as lithium, cobalt, and nickel from the waste sources such as battery waste. Right? Since we are in Japan, let me share a quick history of Japan and the battery innovations. Do you know that the world's first lithium-ion battery was commercialized here in Japan? It was done by Sony, which is used in the camcorder or video camera, which we call in Japan, back in 1991, which is developed in collaboration with the Asahi Kasei by a researcher named Professor Akira Yoshiro. He was awarded the first Nobel Prize in chemistry for the battery developments back in 2019, together with the two other researchers from US. Since then, the world has changed the way the batteries are being used in our portable applications. But do you know where the batteries are coming from? And now the world is moving towards transitioning everything to electrification, be it in your electric vehicles to grid storage applications. This, again, increasing the demand for batteries. The critical materials such as lithium, nickel, and cobalt are required to manufacture these batteries. We require more than 10 million tons of these materials in the current estimation. And Japan government also decided to increase the battery manufacturing demand from current 20 gigawatt hours to more than 150 gigawatts by 2030 every year. Where do they get these batteries? The current mining is very pollutive, which is where your lithium and nickel is being extracted. But again, these supply chains are very concentrated, and everything is concentrated and depending on the few countries. in the current global uncertainty and trade wars, you can't just depend on few countries. You have to develop your own supply chains. At the same time frame, a tsunami of battery waste is being generated from this massive adoption of batteries. This is providing us with a unique opportunity. By recycling the batteries, we can extract the same critical materials that are used for manufacturing batteries. This can reduce our dependency on mining and especially cut down the carbon emissions that goes into manufacturing new batteries. And mainly, we can strengthen the supply chain securities. However, let me show what exactly happening in the current market, current battery supply chain. As you know that if it doesn't grow on plants, it has to be mined. So we mine the materials which will be used for producing new electrodes that goes into cells and packs. When the battery is ready, that will be used in our first life application, be it in your consumer electronics or your electric vehicles. And once it reaches the end of life, they will be collected. If it's not suitable for secondary application, it will go for mechanical recycling. That's where the first phase of battery recycling is happening. So at this phase, we basically crush the batteries into a fine powder known as black mass, which consists of cathodes and anodes. Right now, most of the countries are exporting this black mass into few countries where the refining facilities are available. Again, it is a black gold. It has a huge resource of critical materials. We don't want to let it go outside of the boundaries, rather than building our own supply chains. Unfortunately, the traditional technologies that are used for refining these critical materials are very pollutive and also results in a huge secondary pollution in the form of sodium sulfates. We are changing the way that's the current supply chain is being operational. So at Lincor, we are taking the black mass directly into our process, and using our sustainable refining approach, we extract lithium, nickel, cobalt, and manganese directly in the form of precursors that can be used for manufacturing new batteries. This is how we can become the final link to close the loop of battery supply chain. How do we do that? We have developed an electrometallurgical process that can handle all types of batteries from our consumer electronics to electric vehicles to grid storage applications. So we can recover more than 95% of these critical materials, and using our closed-loop approach, we then regenerate the chemicals that are used in the process, so we don't produce any waste, unlike the traditional technologies in the current market. We are modularly developing this technology, so it can be co-located adjacent to wherever the feedstock is available, rather than exporting the feedstock to third countries. So these are the feedstock and the products that we produce in our lab. And so that we will be more economical, meaning we don't have to build multiple systems to have different processing capacities for different chemistries. And our process doesn't have any emissions. Only emission is the hydrogen. Hydrogen is valuable. We can use it for generating electricity back so that we can compensate the energy consumption for our own process. So comparing with the existing technologies such as hydrometallurgy and pyrometallurgy and direct recycling, we are more advantageous in the chemical consumption so that we can reduce the entire chemical requirements for the process. Because of that, the environment footprint of the process is quite minimal. And these two factors are leading us to reduce the cost of the process, which is how we can build the systems, universal systems, rather than having a single system for single chemistry. Right now, we're at the prototype scale, and we are building the pilot plan by this year. So our journey started at National University of Singapore back in 2019. And since then, we started working on multiple generation technologies. And in 2023, we have started POS, proof of concept, for the Generation 4, which is what universal approach that we are currently commercializing. And since then, we tried to understand the huge benefits of the process and started commercializing from the 2024. That's where we were awarded the Breakthrough Energy Fellowship. Thanks to them, we are expediting the entire de-risking of technology part since 2024. Right now, we optimized our prototype scale, and now we are building a pilot plant in Singapore to process 50 tons of batteries per year. And the plan is to build our first-of-a-kind plant in 2027, which can process up to 1,000 tons of battery waste yearly. And then we want to co-locate these modules at a client's location across the Southeast Asia and Europe. So that's where the commercial launch will be taking place. So how do we plan to deploy this technology is mainly through two phases. One is by refining as service. Basically, we build 1,000 tons modules and place it at the battery manufacturers and the recyclers location. So whenever the waste is available with them, we just use the module to process it. So the final products can be used directly for manufacturing new batteries again. So the second phase is, depending on the feedstock availabilities at the clients, we will then design and build the bigger plants, refineries, so that it can be directly used by our clients at the on-site. So Lincor is not just recycling batteries. We are redefining the way how the critical materials can be refined locally without the need to export them to other countries, so that countries can develop their own natural, it's not natural, but critical resources within the boundaries. So what we are looking for is strategic partners to pilot this technology across the regions. So here in Japan is the third biggest battery manufacturer in the world. So we are looking for feedstock that's available with the gigafactories and the EV manufacturers. So we are targeting them basically in Japan. So even though we are not actively raising the funds, we would be happy and love to talk to the investors who are really interested to make a dent in our energy transition journey. And thank you so much for the organizers and the Breakthrough for providing this opportunity.
Great. Thank you, BingBin and Sai. We're going to take just a minute here and ask a couple of questions about their experience and the journey that they've been on. I just would like to call out how amazing both of you are and your teams and the innovative solutions, the out-of-the-box solutions that they're working on as we see energy demand, the race for critical minerals. You are both working in such important areas, and so we want to keep supporting you and appreciate your leadership. I'm going to start with a question because both of you, came out of early academia or just an idea. And so what's one thing that you've learned going from that very first idea, working in an academic lab, and then turning it towards a commercialization, towards a real product? What's one thing that you could share maybe about that early stage of learning?
Yeah, I think for me personally, my biggest learning is that economy is as important as technology when we're trying to bring the idea out of the lab. And so it's good that we have a cool technology, but understanding the pain points of the customers is actually very important for us to define our path forward from there. Just like interesting thing about us, our technology initially, this whole fold-up idea is try to lay down the platform so we can go under the bridges, because there are a lot of bridges in the US. But then we get the question like, what about other places that don't have the bridges? And does your technology become obsolete over there? And that's with a lot of conversations with the business fellows, with customers, and then we understand that that is not our core value proposition. It's actually that we increase the throughput of an efficiency of final assembly and transportation. That is what solves the pain points of the customer. So that's really how this journey bring me to understand that technology is important, but you also need to think the other side of the coin.
Exactly. What about for you, Sai?
Well, that's for sure. For our case, we are still researchers at NUS. So the first difference is the mindset that we are trying to have being a researcher and an entrepreneur, right? So since we started our journey, the most important thing is the customer discovery, because as a researchers, we all love our technology. We don't want everyone to agree, even though it's not great. So we want to make sure it's really perfect. So we want to talk to the customers, whether what they are thinking as well. So from our customer discovery calls, we understand that it's not straightforward. Once you produce the product, it has to be tested for a long time. So in our case, battery manufacturers has to test our recycled materials for 18 months to qualify for the manufacturing new batteries. So that's a valuable insight for researchers to keep on getting the same purity of the product. So similarly, there are multiple insights that we got from our customer discovery calls with the manufacturers as well the recyclers. And again, as BingBin was mentioning, techno-economic analysis is very, very important because researchers only focus on the technology development, but they always skip the economic parts of the process. So from our side, and thanks to Breakthrough Energy, we were quite active on techno-economic analysis from the early stage. So we are making sure that we are not skipping any other non-realistic assumptions that we're making here. So that is very important for any research to become into commercialization.
So the theme I'm hearing is get close to the customer and the pain point as soon as you can, really understanding the market, what's the criteria that you're going to be working with, and how to navigate that procurement, the demand, all of those things. So the sooner you do that, the better. So both of you are in the Breakthrough Energy Fellows program. Could you just give maybe an example of how it's uplifted your process or a key learning since you've come into the program?
Yeah, for us, again, our journey started last October, November. So since then, we have a dedicated mentor. I think Jane, she is sitting in the crowd. So we have every week a calls with her. You just imagine researchers getting a huge access to a corporate person with a business knowledge. That makes our world entirely different. In fact, even yesterday when you're coming from airport to our hotel, we're still having conversations with how we can make the things different and what we can learn from rich experience that our mentor has. So that kind of support we are getting from Breakthrough. I don't think any other organization can provide that for researchers. So that is a valuable resource that we got. Apart from the grant, of course, capital is required for us to de-risk the technology. But the network that the Breakthrough has, the global one, coming from Singapore, we are given a doors open to the global access. So that was a wonderful thing for anyone based in Singapore can happen.
Yeah, I think I will echo that. It's the community that's really make us to get to critical resources really quickly. And thing is that's kind of mind-blowing for introvert engineer as me, because you can just talk to people and then you get to tap into their network as well. And for example, we got two very good senior engineers that have 30 years of experience from Shell, from our business fellows contacts. And we also, for example, we're thinking about changing our business plans at some point, and then we just yell in the chat groups and think if people have ideas or they have contacts, and then people will just reply as well, I know this person, maybe it's a good idea to talk to this person and that. So it's really, this whole network and community is really help us get to the problem and solve the problem really quickly. And yeah, that's kind of I wouldn't imagine that before.
Yeah, we certainly don't have time to waste, right? So some things that I hear there are community. One of the things in building this program that I'm most proud of is how we've connected these early stage fellows globally. We do have a WhatsApp group that is active daily, and they're all helping one another. Does somebody have a contact here? Does somebody have a template for this that I could use? Does someone have a vendor now that we're seeing what's happening on the global stage? And so it takes a community of support to do this. The second thing is access to resources. And so another thing that we provide through our program is a proprietary resource portal that we've built that houses all kinds of information, investors, mentors, every single module we've ever developed, templates. And so putting all of that in one place and making it easily accessible helps these founders not have to spend the time doing that, so that they can really focus on the technology, the path to market, and having conversations with the highest value stakeholders. And so we're continuing to do that, and we're also open sourcing that. We work with a lot of universities or other accelerators, and their templates feed into our program. And then finally, two other things. I guess you both mentioned a little bit where you're at in your journey, but the first question is, what do you need today?
Yes, I think as I was mentioning at the end of my presentation, we're building capital stacks for our full-size demonstration. So we are looking for partners and that can help us looking for grant opportunities, and we're investors directly interested into investing this project. And also we're looking for partners that could help us answer questions about fabricability and transportation or supply chain strategies for our projects, and also forward thinking about the needs of different markets.
Great. What about you, Sai?
So for our case, we need batteries. We need your waste. If you have waste, make sure it was disposed properly so it comes to the recycler so we can recycle it. So we are building a first pilot plant in Singapore. We are looking for battery waste so that we can technologically validate different types of waste using our system. So we are majorly looking for strategic partnerships with the electric vehicle companies and the battery manufacturers and the recyclers. So if anyone in the crowd knows anyone, please feel free to reach out to me. Happy to take your waste and we convert that into value.
Okay, and final question. If we fast forward 5 years from now, where will you be? I'm going to start with where I hope Breakthrough Energy Fellows will be is it was a huge milestone for us to get our first 100 fellows in the program. Now we've launched a hub in Southeast Asia, but I hope that we have many hubs around the world and that we're supporting hundreds of innovators working on these challenging problems, and that we have thousands of partners that are doing it alongside. So that's my vision, is that we continue to take this playbook and bring it to other parts of the world. So now, 5 years out, what do you think, BingBin?
Yeah, I think hopefully by that time we'll commercialize our platform, and we want to be the first-tier supplier for floating wind farms developers. Meaning we don't want to be the supplier that that will only provide the technology, but we also want to work very closely with fabricators, and then we'll be responsible for the platform that we deliver from head to toe, in a sense. Yeah, and.
For us, again, since we are still at the pilot scale, we want to get the commercial level ready by 2028. So maybe 5 years out, we definitely want to be in Japan. Hopefully, we bring our modules and set up here. So if water waste is produced by industry, we will recycle that. And not only that, again, batteries are just one source. The chemistries has been changing. We had to come up with the new technologies that can handle all types of batteries. So we will be advancing the technology so that it can be integrated with different types of chemistries that will be existed next in 5 years as well.
Great. So as we wrap up here, the call to action for you all, thank you for joining the session. If you can please share the word about the important work we're doing and about the important solutions that you learned today, please reach out to us. And that concludes our program. So let's give a round of applause to these two amazing innovators. Great, thank you so much.
Thank you very much. Please give a big round of applause to all the speakers.